Hey guys, and welcome back. It's Monday. It's the 6th. Hope everything went well with the test on Friday. Hopefully, I'll have those graded here pretty soon. So, hopefully, get those back to you guys as soon as I possibly can. Well, we're done with chapter 3. We are moving on to chapter 4. And as you guys can see, it's just kind of a little overview of what we're going to be covering in this chapter. We're going to look at some exponential and logarithmic functions. We're actually going to go back and review and look at some other composite functions, which we did earlier this semester, and look at some one-to-one functions and inverse functions. A lot of that's mainly going to be this week. So, just again, this is a brief little overview of what's going on this week and what's coming up in these next few chapters. You guys can kind of scroll through and see those on there. So, but first of all, we are going to be covering composite functions. All right. Now, if you go back and remember, composite functions, that's when we're taking an original function and plugging it into another function. All right. So, if you guys look down here, given two functions, f and g, or f of x and g of x, the composite function is denoted by f of g of x. Now remember, this little symbol right here in the middle does not mean multiplication. That symbol right there does not mean multiplication. It means composite function. It's kind of denoted as of. All right. So, or as you guys can see down here, it's f composed with g, hence composite function. All right. But a lot of times we'll kind of say that as of, etc., etc. So you could see it that way. You could also see it just like this down here, which is another way we've seen it. So you could see just f of g. You could see it in parentheses as f of g of x. Again, not multiplying. Or you could see it just like this right here, where it's f and then parentheses g of x is in there. So again, if you guys remember back to what we were talking about earlier this semester, a composite function is when we're taking a function, in this case we're taking g of x, and we're plugging it into another function. In this case, we'd be plugging g of x into f of x, wherever we see any x's. All right, the other thing that we're going to be looking at today is the domain. Now, we've talked a lot about domain this semester so far, so we're also going to be looking at the domain for composite functions. So the domain of f of g of x, it says it's the set of all numbers in the domain of g such that g of x is in the domain of f. In essence, what it's saying is, as long as if it's an excluded value in the domain for g of x, then that means it also has to be excluded in the domain for f of g of x. We'll get to those a little bit later on in this lesson right here, but that's just kind of a little precursor to what we're going to look at later on today. All right, so let's just look at just a basic composite function. Now, these are just a couple visual aids about the domain for f of g of x. So, like I just said, for the domain for f of g of x, you want to look for any restricted values in the domain for the second function. In this case, it would be g of x, because any restrictions in that second function also need to be included in the entire composite function. So first we'd be looking at the domain for g of x and make sure that that excluded value also occurs in the entire composite function f of g of x. Another way of looking at it down here, I think this one's a little bit easier to understand other than this mapping one here. This one should be a little bit easier to understand, I hope. It's just another kind of illustration for you. Hence another illustration. X is the input to the function g of x. So if we put in some x value into our g of x here, we get some value g of x. All right, so we put in an x, we get a y. Now, if that value is an excluded value of g of x, then automatically, because we're kind of going through this machine here, if it's an excluded value in g of x, then automatically it's also going to be an excluded value in f of g of x. So all my numbers for g of x that can be plugged in can also be plugged into my f of g of x, my composite function. So once again, any restricted values in g of x or any restricted values in my second function also are going to be restricted values in my original function, which would be f of x here. So that's just going through and looking at it. So let's just kind of do a quick refresher of what a composite function looks like. So here we've got two separate functions. We've got f of x equals 2x minus 3, 2x squared minus 3, I'm sorry, and g of x equals 4x. So those are my two functions I'm going to be looking at. So let's look at this first one. All right, so the first thing we're doing is f of g of 1. All right, so to write this another way, it might be a little bit easier to see. All right, and you have to excuse my handwriting. I'm using the mouse right here. So this is another way we could write it. F of G of 1. All right, so we kind of have two things going on here. So the first thing that we have, the first thing is we've got to do G of 1, which means I'm taking 1 and I'm plugging it into my G of X function. The second thing I'm doing is whatever value I get with G of 1, I'm going to take that and I'm going to plug it into f of x. So the first step would be G of 1 here. The second step would be to take that function, that G of 1, whatever value we get, and plug that into f of x. So let's look at the first part. So step 1, we want to do G of 1. All right, so let's look at G of 1 first. All right, so in this case, 1 is my x value. 1 is my input. So I'm going to take 1 and plug it into G of x. So in this case, it's going to look like 4 times 1, which hopefully you don't need a calculator for that. So G of 1 equals 4. So if we go back up and look at my illustration, the first thing I do is do G of 1. So in that case, I got 4. So the second piece of that is to take 4, which I just got, and take that and plug it into f of x. So step 2, again, forgive my handwriting, is I'm going to take 4 and plug that into f of x. So f of 4 means 4 is my x value, 4 is my input value. So I'm going to take that and I'm going to plug that right into my f of x function. So it's going to be 2 times 4 squared minus 3. So, good old Aunt Sally. Hopefully you all remember Aunt Sally. She makes good spaghetti. But she says what we've got to do first is we've got to do my exponent. So first I've got to do 4 squared. Well, 4 squared is 16. So I've got 2 times 16 minus 3. All right, if we keep going, simplify that again. Now, good old Aunt Sally says after I do my parentheses and exponents, then we can do my multiplication division. So 2 times 16 is 32. So I've got 32 minus 3, which gives me 29. So in this case, f of g of 1 equals 29. So just to go back and reiterate, first we did g of 1. That's my first step. Plug g of 1, we got 4. Then we took that 4 and we took that and we plugged that into my original function f of x. So then that's where I got my 29. So real quick, let's just pause it. I want you guys to see if you guys can do g of f of 1. All right, so let's kind of come back together. So g of f of 1. Similar concept here. If you notice, the letters are in different order. So in this case, it's not f of g of 1. In this case, we're going to do g of f of 1. All right. So the first thing I need to do, step 1, right there. First, I need to do f of 1. Then, after I've found my value for f of 1, then I can take that and I can plug that into g of x. And that's going to be my second step. All right, so let's look at my first step. Boom. The first I'm going to do f of 1. So f of 1 means I'm going to take 1 and I'm going to plug it back into my original function, my f of x, which is 2x squared minus 3. So let's plug in a 1. So we got 2 times 1 squared minus 3. So 2x squared minus 3. So I got a 1 here. So good old Aunt Sally said I got to do the 1 squared first. So 1 squared is 1. So I've got 2 times 1 minus 3. All right, so next we can do 2 times 1. 2 times 1 is 2. So I got 2 minus 3, which, again, hopefully you don't need a calculator. You get negative 1. So first step was to do f of 1. I got negative 1. So now I'm going to take that value that I got and I'm going to plug that into my g of x function. So the second step, I'm going to do g of whatever value I just got, which I got a negative 1. So do g of negative 1. Which means I'm going to take it and plug it into my g of x function, which would be 4x. So 4 times 1, which gives me 4. So g of f of 1 equals 4. All right, so let's scroll down. Let's look at a couple other ones real quick. Once again, though, I want you guys to take a couple seconds. I want you guys to go through and do these. So you got f of negative 2 and g of negative 1. So I'll take a quick second and go through those. All right, so hopefully it was paused and you guys can have a second to go through that. So let's look at f of negative 2. So this, another way to write this would be this right here. So f of negative 2, right there. So same concept, except now we're just using the same function. So the first thing I'm going to do is I'm going to plug in negative 2 into my f of x function. Then whatever value I get from that, I'm going to take that and plug it into f of x. So I'm going to use the same function twice, but I'm going to get two different values more than likely. So first step, step 1. Let's do f of negative 2. So f of negative 2 means I'm taking negative 2 and I'm going to plug it into my function f of x. So that's going to be 2x squared minus 3. So again, in place of x, I plugged in a negative 2. Now, negative 2 squared is going to be 4. So we got 2 times 4 minus 3. Hopefully you don't need a calculator. 2 times 4 is 8. 8 minus 3 is going to give me 5. So f of negative 2 equals 5. And I'm actually going to pause it right there.